So I used to be in strategic planning, and I'm being moved to client value optimization. I'm also studying medical informatics at Northwestern, and I like technology, Python obviously, data, and Star Trek. That should be a brown Vulcan sun. I don't know what happened. TNG, of course, TNG. So we've all seen this before. Anytime I need to read from a file or write to a file, I go on Google, I'm like, Python, read, write. I get taken to this page on the python.org tutorial. We look at this example, we copy it into our use case, adapt it for what we need to do, and then we just go on with our way. But how many of us have actually looked into what a with statement actually does? So please join me on this journey while we figure it out. So the with statement was introduced in PEP 343, and it's a control flow structure that encapsulates try, except, finally blocks for convenient reuse. So what does that mean? Anytime you have some sort of cleanup step, so think open, close, lock, unlock, we're going to use a with statement to encapsulate that for us. So as a result, our code becomes a lot cleaner and a lot more readable. So what's a context manager? A context manager is any class that contains the dunder enter method and a dunder exit method. And so the dunder enter method is executed before the with statement is entered. And once the with statement is exited, the dunder exit method is executed. And just a little note on terminology, dunder means double underscore. So when I say double underscore enter double underscore, I can shorten that down to dunder enter. Just a little note on some of these dunder methods. The dunder enter method should return an object, and the object it returns is assigned to the variable after the as keyword. By default, we don't have to return anything, and it's optional, but a common pattern is to return self, and then add more functionality to that context manager class. The dunder exit method is called on the original object, not on the object returned by the dunder enter. And if an exception occurs when we're in either the dunder init or the dunder enter method, the with block is not executed. So this also means that whatever's in our dunder exit block, that's also not going to be executed. So what if we have an exception? We'll come back to that a little later. So let's just trace through what we know. We'll create a class, call it foo, obviously. Dunder enter will just print something, return self. Dunder exit takes the self argument and some exception arguments. So we got type, we got value, and TB, which stands for traceback. And then we'll just print that it was called and go into the REPL. Create a with statement, create an instance of our object foo, and inside the with statement, we'll just print something. So you can just see it goes dunder enter, inside the with, and then the dunder exit. So pretty much what we expect. So once a with block is entered, it's always going to go to the dunder exit method. So it's always going to be invoked, even if an exception occurs inside the block. And so the way we can handle exceptions within these context managers is to put code in our dunder exit method and then return true to suppress the exception going up the chain. So let's go back to our foo class. So we'll just do the same class as before, but inside of our with statement, we'll raise an exception after our code. So you can just go to the output. So it goes enter, inside, exit, and then we have some code about an exception with a traceback. So now let's try to create a class that can allow us to handle exceptions within these with statements. So we'll create a class called foo2, have a dunder init method, a dunder enter method, which is the same as before, and then a dunder exit method. And this one will just have some code where we have, if there is an exception, we'll have some code to handle. We'll print that we handle it and return true so we can suppress it going up the chain. Go into the REPL, create an instance of our new object or new class, print inside with, and then raise an exception. So you can see in our output, we don't have that traceback anymore since we handle that exception. Now you're probably wondering, when can we use context managers? Really good question. So anytime we have a cleanup step in our code, that's when we should use a context manager. The canonical example is, as I mentioned before, the open example, where you could just go with open the file as f, do whatever you need to within the with statement or within the with block. And then once that's over, Python will close it for us automatically. We can also use it for testing. So if we're trying to test if our code generates some sort of exception, so pytest provides their raises function can be used as a context manager. So we can do with pytest.raises the exception that we're trying to raise, and then in the with block we can put the code that is going to raise that exception. Unit test in the standard library also provides the assert raises helper function, and we can use that as a context manager. But there was a talk, I think a couple months ago, about pytest. So use pytest. It's a lot better. Fixtures will change your life, trust me. So other use cases are managing database connections, synchronizing access to shared resources, so think threading and locks, logging around certain actions. So you can write your own context manager to do that for you, or you can use something like lithoxyl, where you can package actions around pieces of code that you want to log. And there's a bunch of additional resources. You can check the slide later on called Additional Resources. I also want to make everybody aware of the contextlib package, which is part of Python's standard library. This module provides a lot of common tasks that involve the with statement. So you have a bunch of utilities that can make your life already pretty easy. So there's a lot of ready-made context managers. So that problem that we talked about before, where if an exception is raised within the dunder init or dunder enter method, we can use something called an exit stack and deal with that in that paradigm. And we can also create a context manager using a decorator and a function with a generator, and use the context decorator class to create context managers that can be used as function decorators. So let's talk about the example project I used context managers in. I have a script running on AWS Lambda that goes to my Twitter feed, grabs the latest post every 6 or 12 hours, and throws it into a Mongo instance running on MLab. So I wanted to write a context manager to query the database, query the collection, and analyze the tweets by hashtag. So before we start using context managers, let's sort of see the old paradigm with the try finally block. So here we have our code which creates a an empty list of tweets. In our try block, we try to connect to our database and set up our connection to the collection, and then we'll actually query the collection for the for the hashtag we're trying to find. And in the finally block, we'll close the connection, and then we'll at the end return the list of tweets. So yes, this does work, but we just learned a much more Pythonic way of doing things. So let's sort of see how we can implement that. So we'll start off by creating a class, call it a Mongo collection class. We'll create 3 methods. The dunder init method sets up the connection to Mongo and links to the collection that we actually want to query. The dunder enter method returns a reference to that collection, and then dunder exit just closes the connection to the database. And now we can create our function where we just use a with statement and create an instance of our Mongo collection, and then just search our tweets and return a list for what we get back. So this code is a lot cleaner since we abstracted away a lot of our database connection information in our Mongo collection class. And just a little note, I used f strings because 3.6 is awesome. And so just at the end there where I say tweets equals call, there's an f before the string, and that's just a better way to format strings that they just released with Python 3.6. Check it out, it is worth the price of admission.
Hell yeah!
Yeah, 3.6. So additional resources, I actually wrote a blog post about this if you want to experience it in another medium, want to get a little bit more of me. I also recommend the last link, which is a PyCon talk on context managers and function decorators. So here's my contact information. I also tweeted a link to the slides. There's a link to the slides there, so thank you for your time. I will take your questions. How do I unit test it? That's a good question. So I guess you can.
PyTest it.
So for the Mongo one, I think I just mocked it out using Mongo mock, and so that's how I unit tested it. Just made sure it was returning what I sort of expected to with my defined data sets. Good question. Love testing.
And what happens if I'm opening and closing files? Why shouldn't I just do f.open, f.close every time I have to open and close?
So the question was, why should I not just do f.open and f.close? It just makes it a lot easier for you, and it's something, it's one less thing for you to worry about. So if you use the with statement, just open it, it'll automatically close it. Don't have to worry about leaking memory or whatever.
So when you're working on a file,
does the rest of the code have to be in the indented block? Or like, how do you know when you can just keep coding outside of the indented block of the width statement?
So if, like, say you have, let's actually show.
Can you repeat the question?
Yeah, okay. Yeah, I'll do that in a second. So the question was, when do we know when we have to have code inside of our width block? So say for something like this, I would only really put code inside of this statement, or sorry, inside of this, this block where I need to do something with the file. So I would probably have like a 4-line in F and read in the line. And then once I read in the line into a data structure, I would do whatever I need to outside of the width block.
Are there any context managers other than Open that are built into Python that are cool?
Oh, so they have a closed one as well? Oh yeah, so are there any other context managers in Python that are cool? So if you look in the contextlib, there's closing, which is also cool, and there's exit stack. I haven't really used too many, so I will say this is, I came into context managers around a month ago when I had this problem. So yeah, I will definitely look into that and update these slides accordingly.
What was the problem you had?
I'm sorry?
What was the problem you had?
Oh, so the problem, I guess, was I was using try finally. So I came into Python from JavaScript and C#, and the pattern there was to use like the try finally blocks. And it just seemed like there was a better way to do things, and there turned out to be a better way. I actually talk about that a lot on my blog if you actually want to take a look. Plug to my blog, check it out, it's awesome. I don't know how to use Slack, but I will learn how to use Slack. Yeah.
Thank you.
Thanks a lot, guys.